Okay, so this is the second half of the lesson, and this one is going to be on page 333, and it's dependent equations. Okay, dependent equations. If I have this equation right here, y minus x equals 2, and I multiply the entire equation by 2. So, in other words, I would get 2y minus 2x equals 4. Okay? I know that these, I could do it, multiply it by 3, I could multiply it by 100. As long as I do it throughout the entire equation in all three places, I know these equations are going to be the same line. Okay, but let's assume that we don't know that this is going to be the same line, and we need to check that. Okay, we want to check it algebraically to see if it's going to be the same line. Okay, so going back, we're going to use the substitution method, and we're going to use the elimination method to check our work to see if it is the same line. And if it is the same line, they are going to be known as dependent equations. Dependent equations, okay? So first we're going to use the substitution method, okay? This is substitution, okay? And the equations are y minus x equals 2 and 2y minus 2x equals 4. Okay? Substitution method. We need to make y equal to something. Y in this equation right here, y is going to equal, if I move x over to the other side, I'm going to add x there. I'm going to add x there. Okay? So what I want to rewrite this as is y equals x plus 2. I wrote equaled. Y equals x plus 2. Okay, now I'm going to substitute y, this is what y equals, x plus 2 in to where y is on this equation right here. So it's going to be 2 times x plus 2, right? Because y equals x plus 2, and I'm substituting it right there, minus 2x equals 4. Do the distributive property, it's going to be 2x plus 4 minus 2x equals 4. Well, these are like terms right here. One's positive, one's negative. 2x minus 2x is 0, and I'm left with 4 equals 4. So with the substitution method, yes, I have confirmed that these are dependent equations, okay, with the substitution method, right? Now, I'm going to do the elimination method, okay? You need to know how to do both methods. We have the same two equations, right? Now, I'm going to have one of these, it doesn't matter which one, be the opposite of this one, okay? So in the book, what did they do? They made it positive 2x. They made this one up here positive 2x. So to make that positive 2x, I need to multiply the top one right here by negative 2. So I'm going to get, from this one right here, I'm going to multiply the whole equation by negative 2, and I'm going to get negative 2y. Negative 2 times x would be positive 2x equals 4, right? And what's that going to do? Well, now I'm going to, oh, I'm sorry, I forgot to multiply this one by what? What am I supposed to multiply this one by? This one by negative, what did I multiply it by? negative 2. Negative 2. So it would be negative 4, right? It's going to give me 2y, negative 2y plus 2x equals negative 4, right? And what do I get? Well, I get 0 there. I get 0 there equals 0 there. So 0 definitely equals a 0. So yes, it gives me another. Now, what was this method? This was the elimination method, right? The other one was the substitution method. Two different ways of figuring out if it's a dependent equation or not, okay? All right. So now you have enough information to do the lesson 81 and find out if they are consistent equations, inconsistent equations, or dependent equations. Consistent equations, the graphs consist of consistent equations will intersect. The lines will intersect at a point. The graphs of inconsistent equations will never intersect. They'll be parallel. And dependent equations, meaning are they equal or not? Are they equivalent equations or dependent? Dependent or equivalent means the same thing, okay? And you're good to go. I'll see you tomorrow.